Alright, hello ladies and gentlemen, this is Mr. Nkosi. I want us to look at this previous question paper that was written July 2022 on the 13th, July 2022 on the 13th. So we've done question 5. I want us to look at question 4. We have to, I think there is no question 7. Understand? So at the end of the day, it is our duty to upload all of them all together. So this is the question that I want us to look at. We've been done this one. We've done this one. So we've done this one. If you want to see the solution of this one, you can just easily tune in there by our YouTube channel. You'll find the solution of this one. Or if you're already with us here on YouTube, you can just scroll down the videos. You'll find this one where we were drawing line to line, point to point, up until at the end. Are we together? So from that, I want us to look at this one. So this is simple, straightforward isometric drawing and 2 isometric drawing and 2. So it is very much to read the question, because you might find that the question is saying do not attempt this question. Please go to the next page. You understand? So it is very much important to read the question first. So figure 4 shows 2 views of a workpiece in third angle orthographic projection, full stop. So we've got 2 different types of angle orthographic projection, isn't it? So do not draw the given views, but draw to a scale 1:1 an isometric view of this workpiece. Point P must be the lowest point. No hidden details. It is necessary. So that was it. So the very first thing that we picked up here is that these views are given in what? In third angle orthographic projection. So it takes one to remember third angle orthographic projection. What is the difference between these two? The third and what? And the first. And we confirm again with what? With the projection symbol. Didn't I upload it? This one? I think I've uploaded this one. But for the sake of, because I remember teaching me drawing here. Did I upload it? This one? Okay. But then anyway, let's continue for the fact of for the beneficial of those guys whom are watching us live from TikTok. So this is the projection symbol. So remember, we've got 2 different types of projection symbols. So this was simple, straightforward, actually. All together. So point P must be the lowest point. We mustn't get anything below than point P. You are getting any point below point P, consider yourself out of order. What I like about the drawing, you can be able to see what I'm doing now, I'm out of order. Lee Love is saying engineering drawing kills me. Okay, no, my sister, don't cry. We are here for you, and I'm not even alone. I'm with my brothers. Just go to YouTube channel. You will find us there ready for you. You understand? So now let us see what is going to be our first step. So let us go together. So this one was the simplest one, actually. So the examiner of this previous question paper wanted every student in the final examination to get what? These 15 marks. Because this is more like grade 10 stuff, you understand? There are those marks that they will be just simple and straightforward. How? Like this. Start with the what? With the horizontal out of dimension line. Like this. Horizontal out of dimension line. Let me just pull it just a little bit down. Okay. Then now at the little bit center, I can somewhere here I can draw out of dimension a faint line again that will be perpendicular against this one. Then from there I will where these two lines of mine, they are perpendicular to each other. That's going to give me the what I'll name the what that point P, this P that they are actually talking about. Okay, the point that I can also emphasize here is what is this one. The question was like in third angle orthographic projection. So it is very much important, because you might find that they are saying those views are given in third angle orthographic projection. Yes, we confirm that with what, with the projection symbol. But when you read the question, it will be like draw this according to what, to first angle orthographic projection. So it is very much important to read or to go through the question. Understand? So yes, my dear, go and check it out. Is going to, I'm 100% sure you are going to find something that is going to help you there by our YouTube channel. Really love. Okay, thank you. Let us go now. After we've gotten this point, I am going to take, remember that we throw away as if we throw away this ruler 45 degrees set square, as if we throw it away as if we will never need it again. On this topic, we do not use this one. So now I'm going to take this particular one, the 30 and the 60 anti-clock and clock. So from point P, I am going to have a faint line that's going to be like this, faint at an angle of 30 degrees clockwise, and point P again, angle 30 anti-clockwise. There you go. Right, then I bring back my my views. Okay, so these two views are given in what, in third angle orthographic projection. Alright, which means this is supposed to be my front, this is supposed to be my what, my top. And I have to put the front view on my what, on my left hand side, so that the right view, which is omitted here, it will be on my right hand side. So come back to your drawing. What separated the right from left is the vertical what, point P line. So which means this side, according to third angle orthographic projection, remember this one was the what, was the previous drawing. So this side, according to third angle orthographic projection, I am going to have a what, a right view. And this side, according to third angle orthographic projection, I am going to have what, this front view, this right view. Hey one. So which means, assuming the right view was given here, whatever dimension that I see from the right, positioned, dimensioned label from the right, I will have to correlate it. I will have to correlate it this side altogether, because I won't be putting it this side, because this is given in what, in third angle orthographic projection. So saying which engineering drawing is this? Please help. This is engineering drawing, nated short course, my sister, nated short course engineering, mechanical engineering drawing. Are we together? So now let us go. So we know that the front view and the top view, they will always share the same what, same length. And the front view and the right view, they will always share the same what, height. And the top view as well as the right view, they will always share the same breadth or width, whatever you might call. So now, why am I saying that? Because now I'm looking for a dimension from here till there. It seems to be missing. So I'll just come just up there and read it right from the what, from the top view. From point P coming this side is what, is 8 millimeter, and I can see it is what, is solid. Take your 30 millimeter ruler from point P, coming this side is 80 millimeter. So there is your 8. From here to right there. Without fear or favor, I can draw it dark. All together. So where my 80 millimeter is good as if I'm moving from here till there, isn't it? So I see an upgoing line, isn't it? So now I can go up faint. Why am I drawing faint for now? Because of I am not yet sure how high it's supposed to go. Up until I come to say, okay, it's what is 45. Then I, on a well recorded line, I record a dimension. I cannot, you'll see students doing like this. No, it's not, it's wrong, because what if you are not accurate? So you must firstly get a faint line recorded drawing, you understand? Then on top of that recorded correct line, you can record it a dimension, you understand? So 45, there is my 45. From here to right there, I can draw it dark without fear or favor. I'm drawing it dark not because of I'm favoring it. It's actually dark. You can see it clearly. You understand? So now where 45 ends, I can put a faint line coming this side and another one at this angle, 30 anti-clockwise. Faint for now, you understand? So from there, let me just zoom in a little bit. The guys of YouTube, yes. So from there, from this side coming this side, I can record what a dimension from here till there is. I seems to be not given. Leave it like that for now. Come back and get this from point P going up, which is from here till there. So I want to re-record dimension twice, so it will be still the same height. So I'll just extend this line just a little bit. Then now from point P going up, dark, not because of I'm favoring it, it is actually dark. It is actually dark there. It is from there till there. I want. Okay, so now where your 45 ends, to go back down to point P, we've got 15 millimeter and 15 millimeter. You understand? So I can do that. Remember the scale is 1:1, isn't it? So there is my 15, the very first 15 here, the second one here, because 15 times 2 is giving us 13. So there it is. So after I've gotten it, I can just draw this one faint and have the second 15 faint all together. So now let me see, is this accurate? Because I was not sure this T-square keeps on. I am not convinced, because from there till there it seems to be not. The T-square was squeaked. Yes. Okay. So I have to just erase it just a little bit. So from here, there you go. Yes. So now I drew them faint, isn't it? I draw them faint. So from there, let's see where to go now. The dimension from here till there is how much? From here till there is 45. You understand? So and this 45 and 60, they are actually within the center of what? Of 80 millimeter. So which means I must go back to where I started to get the center. The center is what is 40. There it is. The center. After I've gotten the center, yes, it's now clear enough. So I can project it up just a little bit. And coming up, I can just project as a constructional line. You see how slow I am, because I want it. I don't want to find ourselves doing this again. I don't want to find ourselves doing this, especially this particular one. I want everyone to understand. That's how slow I am. And I hope you guys, you are drawing with me. You are also with your drawing what you call drawing instrument. Okay, so 45 divided by 2 is giving us you must have your calculator by your side. 45 divided by 2, how much are you getting? TikTok guys, I want to see, are you watching with me? Are you with me? 44 divided by 2, how much are you getting? You must be getting 22, isn't it? So there's my 21, 2. So this is 22. So KB is saying, no, you're supposed to get 22. Thank you very much, my brother. So there is my 22. I put it at the center, and then I mark at 0, and I mark at 44. There is my 44. So which means from here till there, without fear or favor, I can have it dark already. Is this one from there till there. So again, from here till there, I can have it soft, which is this one from there till there. So now I can go down with 15 millimeter, of which is what we've done it. We've done it already. So there you go. There you go. So now after we have this, do you see that from here till there, we have to go back with what? With 60. So you're going to say 60 divided by 2. How much are you getting? Because this hidden details, they are giving you the what? This 60. So, and the 60 is within the center. So, okay, thank you, my brother is saying we are getting 30. So I'll come and put my 30 millimeter at a ruler at 30 and mark at 0. From here till there is my 0 and 60 from here till there. So it's which one? It's this one, from there till there, from there till there. You see how slow I am. I'm actually teaching even new beginners. I've taught people that they've never held even a pencil like this, and today they are good. You understand? Because this is simple only if you go step by step, point by point, and understand. So now I'll move from there till there with what? With 15, of which is what we've done it already. So which means I'll just go from there till the vertically, from there till the vertical with my T-square like this. Or you can still do with your T-square attached to your drawing table or drawing board and your set square angle 90 degrees vertical. Like this you go, and like this you go. You see, so we've gotten what seems to be not given dimension. So it's good as if I'm at this point. If I'm now here, I want to move from there till there, which is this one, from there till there. You understand? So now that one you can even do it with your 30 millimeter ruler. Why? Because of you have already constructed the line. So this is what you see when you're standing on your on your front view. So it's simple. So now you just take the lines like that. You understand? So at an angle of 30 degrees anti-clockwise. So this one must go. So let me erase this one. I don't need it anymore because I needed actually it from here till there. From here till there, I don't need it anymore. I can erase it before it confuses me. So even this one must go. Even this one must go. All of them. This one must go. This one must go. This one is already there. Excuse me. So now once you've took your lines like this, so we are now going to consider the left view or the right view. Is it given? It's not given. So then you will know what the right view as well as the, oh Jesus Christ. Okay, so So where are we? So like as I was saying, that the right view as well as the top view, they will always share the same width. So which means from here till there supposed to be what, 50 millimeter. So I can come from point P, from here, there you go, it's my 50. I can even draw it dark, you understand? There's my 50 millimeter, and I go up without fear of favor. It's already dark, isn't it? Even this one has to be dark or solid. A1. Even this one dark. I'm now just finishing it up. There you go. How did you draw this line? You drew them your T-square like this, as well as your what you call your set square like this, eh? So you just push it till at this point. There you go. There you go. Even this side I can do it once. There you go. There you go. There you go. And there you go. And guys, to tell you the truth, student that wrote this paper, actually they were supposed to get all these marks. You understand? The marks that you where you can just fumble a bit is what is isometric, because it's isometric cycles, because this is actually grade 10. You understand? So from there you go down. There you go. Yes. So if the from here till here is 50 millimeter, I can come back here and have the same 50 millimeter. So from there is my 50. So I can, you understand, get it dark so that it will go up like this. And so I am actually expecting, I would have expected everyone to at least reach this extent. You understand? I would have expected everyone at least to reach this extent. You understand? If I was teaching this one, or I was actually examining, be an examiner of this, or a marker, guys on YouTube, are you still with us? Okay. TikTok guys, are you still with us? Okay. Okay, so I'm sorry I cannot read some of your comment because I'm actually concentrating here, so I don't know who can reply your comment. So now once we're here we are going to have a center, because you see this cycle of what of ours, it has got two center. So from here till there is the center, so we are going to take the center like this. There you go. Let me not draw it as a center. Then let's get the center of 50, which is 25. The center of 50, this is 50, isn't it? From here till there is 50, so the center is 25, isn't it? There it is. Right, then you can erase these ones before they confuse you. Let me also erase them so that you see what is happening here. So this is the center, so I can take it like this. This is the other center. There you go. You see where they are perpendicular to each other. So let me just extend this one just a little bit. So now we are going to draw a diameter 30 at an angle of 30 diameter 30 at an angle of 30 degrees anti-clockwise and clockwise, which means an isometric cycle altogether of 30. So to draw diameter 30, we divide our diameter into 2, which means it's 30 is 15, isn't it? So take your drawing compass. This is it. Okay, so I am going to open it to 15 millimeter, which is the half of 30, isn't it? This is it. YouTube guys, are you still with us? Yes. Is this one 15? So I'll come and place this 50 drawing compass of mine where these two centers are perpendicular to each other. So that is why I had to get the exact point. So they're actually cutting each other, they're crossing each other. So I mark this is 15, and I mark this is 15, and I mark this is 15, and I mark this is 15 all together. So we are creating the square. So I am going to have, so in case you don't see it clearly guys from TikTok, you can just tune there by our YouTube channel where I'm teaching isometric cycle. We are going to see some clear points and lines there in case this one is not clear to you. So we are creating a square that should be at an angle of 30 clock and anti-clock. So there it's a square already. So you know the properties of the square, all the sides are what are equal. Let me just zoom it in a little bit for the guys of TikTok. So we are having the square now. If you don't see it, assume it, just assume it's there already. I'm joking. Let us number our square so that you see it clearly. You know the square, it has got what? 4 corners, isn't it? So this is the corner. I can say this is 1, this is 2, this is 3, this is 4, isn't it? So we are already having 4 corners, which means it's a square indeed. So let me just zoom it a little bit as well. Then from there we are having centers. So between the point 2 and 3 there is a center. Between point 1 and 2 there is a center. Between point 1 and 4 there is a center. Between 4 and 3 there is a center. You understand? So 1, 2, 3, 4. These are corners of this square altogether. Just assume this one is not there altogether. So point 1 and 2 there is a center point. I can give it a name as what? A. Point 3 and 2 there is a center. Okay, center point. Let be C, B. Let be B. Let it be point B. So point 3 and point 4 I've got a center. Let it be point what? Point C. Point 1 and point 4. Point 4 back to point 1. I have a point again. Let it be point B. D. So if you check numbering, it is not actually recited what is supposed to be numbered, as long as your constructional lines are visible, and if in case you number, as long as your numbering is consistent. So you can see numbers are in are actually in their order. I didn't just say this is 1, this is 22, this is 3, this is. If you decide to use a number, let it just be like that. And if again the center point, I've decided to use alphabetic points. I didn't mix. You can still use Roman figure 1, Roman figure 2, Roman figure 3. You understand? As long as they are consistently. So now this is an isometric cycle. We are going to use the banded method, whereby we are going to join the two longest opposite corner. I'll try to be fast on this one now, because we are having plenty drawings there by our YouTube channel, whereby I am actually teaching how do you draw isometric cycles. This is our YouTube channel. How do you draw isometric circles? So let's continue. We are going to join the two longest opposite corner, and these two corners of ours, they are numbers. Yes, as much as you can see, 1 2 3 4, they are numbers. So we are going to join point 4 with point 2. Faint, there you go, faint. And do you see that when we are joining the two longest opposite corner, our point center, I can give it a name as R, the reference of all the points that we are about to get now. You understand the reference? So the time we joined the two longest opposite corner, our point R was cutted, and I think the posse, it was supposed to be right there, not something nearby. You understand? So now we are going to join a point corner to a center point. We are going to join a corner to a center point and a center to a corner. And these two lines of yours, they must be parallel to each other. So point 1 must be joined with point B. Point D must be joined with point 3. Point 1 with what? Point B. And point D, which is the center of 1 and 4, isn't it? Join with what? With point 3. There you go. Then these two lines, they are parallel. So the time we're joining a corner to a center point to a corner point, our two longest opposite corner, it was cutted, which is that one. So we can give it a name as Roman figure 1. So I have a point there, and I have another point right there, which I can give it a name as Roman figure 2. But then by look of things, our cycle, this side, it won't be shown. It won't be shown. Remember, the question said no hidden details. It is required. So do not show hidden details, and you'll be actually wasting your time in the final examination or in your internal examination. So now I can place my drawing compass at Roman figure 1, further extend to point B. It's too small, right? Point B, and I can firstly check whether is it coming all right. If it's not coming all right, if it's somewhere there or up there, which means there was somewhere where you were missing. Let me just zoom it. There is somewhere where you were missing points, and for instance, like this one of mine, I can see that there is a point that I miss. Can you see? Especially when I'm joining point 4 and point. Do you see that it was supposed to be exactly at this point? Especially 2, it was supposed to be exactly this point. So make it a point that before you draw, firstly check. If it's not joining, you can make some little bit of adjustment. You understand? So what I know is that I have to place it here to D, and it has to start to draw from B to A. Is it coming? So it's not coming nicely, so I can easily adjust it just a little bit. There you go. Then you can draw it dark. There you go. You can draw it dark. There you go. So I've tried to zoom it in for you. So now to get this side, we're supposed to place the drawing compass at point 3, further extend to what? To point A, isn't it? And this arc of yours must start from A to what? To D. So 3 to A. So there you go, and it's supposed to be dark till here, because from here going in is now the bottom part of this part of your of your workpiece. You understand? So to close it, this side, we are going to place our drawing compass at point 1, further extend to point B. There you go. There you go. So I can stop there. You can draw it dark. So let me zoom it out just a little bit so that you see where are we. A1. So that's how it is. Even YouTube, zoom it out just a little bit. So that's how it is. Let's see, are we going to see the thickness of the hole? Sometimes it won't be possible, you understand, especially if the thickness is big, you won't be possible to express it. So how are we going to see the thickness of the hole? We are going to project, because the thickness of the hole is going to be expressed by the what? By the parallel arc. The way you draw this arc, you are going to draw an arc that would be parallel to this one somewhere there. How did you draw this arc? You drew this arc by placing a drawing compass here till there, isn't it? So where were you placing a compass at point 1? So it is the same point that's supposed to be taken vertically down. You understand? So now from point 1 till down there, you're going to what? Record the dimension of the thickness. The thickness is this one. You can easily record it right from here. This is the thickness. Then I come and place it at 1 and I mark. Sorry, then I mark there, which means my point 1 is down there now. So now I come I come back and record. I drew this arc by placing my drawing compass at point 1 to B. There it is. So now I'll have to take point B vertically down as well. Vertically down as well for now. So now I come and place it here from here. There you go, dark till here. I can stop. So that would be the thickness of the hole. That should be the thickness of the hole. If this was a portable and you can just put it on the ground or on the green grass, you are going to see the green grass here and the green grass there and the green grass right there. So which means the bottom would have just hold it like this if it was possible to hold it like that. So thank you very much guys for watching. That was Mr. Nkosi. See you on the next video. Please don't forget to subscribe on our YouTube channel. Subscribe and like and comment. If there's something I've left, please let me down there on the comment. And please don't forget to subscribe. Don't watch without subscribing. TikTok, those whom they don't know us, this is our YouTube channel. It is one of the biggest YouTube channel as well. We would like to appreciate you guys, the effort, the data, your time that you are spending there watching us. At the end of the day, that's what put today we've got cameras because of you guys. You are watching us today. We are looking forward to grow together, and we would like to appreciate. Appreciation, it is very much important. The moment you watch us there, you must know what you are doing a different to somebody. So it is very much important. Thank you very much guys. Please, when you get there, just subscribe and like the video you are watching at that time. Comment, even if it's just one word comment. Your comments are very much important. They are the one that keep motivating us, you understand. So this is the YouTube channel that is actually dealing with drawing only. Engineering, graphics and design, grade 10, 11, 12. Engineering drawing N1, N2, N3. Mechanical drafting N4. Boiler maker drawing PSSD N1, N2, N3. So you find all what you might be looking for at this channel. So thank you very much for watching. That was Mr. Nkosi. See you on the next video. Okay.